Season 5, AI and Decision Making. Episode 4, Why Algorithmic Neutrality is a Myth. One. Introduction, the most comfortable lie. When algorithms make decisions, people often feel relieved. A machine cannot be racist. A model cannot be political. A system cannot be unfair on purpose. So a comforting belief forms. Algorithms are neutral. This belief is widespread because it reduces anxiety. If the system is neutral, we do not have to argue about values. We do not have to blame anyone. We do not have to confront power. But algorithmic neutrality is a myth. Not because every engineer is malicious. Not because every system is designed to harm. Because neutrality is not a feature you can install. Every algorithm reflects choices. Choices about what to measure. Choices about what to optimize. Choices about what to ignore. Choices about who gets protected. Choices about whose errors matter. This episode explains why neutrality is impossible in algorithmic systems, how the myth survives, and why believing it makes society more vulnerable. 2. What people mean by neutral. When people say algorithms are neutral, they often mean one of three things. 1. The algorithm treats everyone the same. 2. The algorithm uses data, not opinions. 3. The algorithm does not have emotions or prejudice. All of these statements can be partly true. But they do not create neutrality. Treating everyone the same can still produce unfair outcomes when the world is unequal. Using data can reproduce past injustices when the data reflects history. Lacking emotions does not remove bias because bias can be encoded in goals and measurements. Neutrality is not the absence of feelings. Neutrality would require the absence of values. And algorithms cannot operate without values. 3. The first reason neutrality fails: algorithms need objectives. Every algorithm has an objective. Maximize accuracy. Minimize risk. Increase engagement. Reduce cost. Increase conversion. Detect fraud. Predict churn. An objective is a value choice. It defines what the system considers success. Even if the objective is described as technical, it reflects priorities. For a social media platform, maximizing engagement is a business decision. For an employer, minimizing turnover risk is a management decision. For a bank, minimizing default risk is a financial decision. These objectives are not neutral. They serve institutional interests. The algorithm enforces the objective. So even if the algorithm is mathematically correct, it is still value-driven. 4. The second reason: data is not neutral. Data is often treated like raw truth. But data is not a mirror of reality. Data is a record of what was measured. And measurement is selective. Some things are tracked, others are ignored. Also, data reflects social conditions. If a society is unequal, data reflects inequality. If certain groups were excluded historically, data reflects that. If policing targeted certain neighborhoods, crime data reflects that targeting. So when a model learns from historical data, it can reproduce historical patterns. This is not because it hates anyone. It is because it learns correlations. Data is shaped by history. History is shaped by power. So data carries power. That makes neutrality impossible. 5. The third reason: proxies create hidden judgments. Algorithms often cannot measure what they truly want. So they use proxies. A credit system wants to measure trustworthiness. It uses payment history. A hiring system wants to measure competence. It uses school prestige, employment continuity, or keyword matches. A policing system wants to measure threat. It uses location or prior contact with police. Proxies can embed inequality. If employment continuity is used as a proxy for stability, people with unstable lives are penalized. If school prestige is used as a proxy for competence, wealthier applicants are favored. If location is used as a proxy for risk, segregated neighborhoods are punished. The algorithm appears neutral because it does not use explicit categories. But proxies recreate those categories indirectly. This is how discrimination becomes hidden. 6. The fourth reason, metrics define what counts as fair. Fairness is not one thing. Different definitions conflict. Equal treatment. Equal outcomes. Equal opportunity. Equal error rates. Minimizing harm to the worst off. Maximizing overall accuracy. These are not the same. In many cases, you cannot satisfy all fairness goals at once. So designers must choose. Which errors matter more? False positives or false negatives? Who gets protected? Who bears risk? These are moral choices. When an algorithm is deployed, it enforces one version of fairness, often without public debate. So neutrality fails because fairness itself is contested. 7. The fifth reason, optimization shapes behavior. Algorithms do not just measure society. They shape it. When a system ranks content, creators adapt. When a system scores workers, workers adapt. When a system scores risk, people adjust behavior to avoid risk signals. This creates feedback loops. The algorithm changes incentives. Incentives change behavior. Behavior changes the data. Data retrains the model. The system becomes self-reinforcing. Neutrality fails because the algorithm is not passive. It becomes a force in the world. A force cannot be neutral when it changes the environment. 8. The sixth reason, deployment is never neutral. Even a well-designed model can cause harm in the wrong context. If a predictive system is deployed where resources are scarce, it becomes a gatekeeper. If a scoring system is used to justify denial, it becomes exclusion. If a ranking system is used to monetize attention, it becomes manipulation. The same model can have different effects depending on what it is used for. So neutrality cannot be assessed only in code. It must be assessed in outcomes. And outcomes depend on power. 9. Why people keep believing in neutrality. The neutrality myth persists because it is useful. It is useful to companies because it reduces accountability. If the algorithm is neutral, the company is not blamed. It is useful to governments because it provides a justification for enforcement. If the algorithm is neutral, the state can claim objectivity. It is useful to managers because it makes decisions defensible. If the algorithm is neutral, discipline looks fair. It is also useful psychologically. People want to believe decisions are objective, because that feels safer than confronting inequality. So neutrality is not just a misunderstanding. It is a convenient story. 10. The math makes it fair fallacy. Many people confuse mathematical complexity with moral legitimacy. If a model is complicated, it feels scientific. If it is scientific, it feels correct. If it is correct, it feels fair. But correctness is not fairness. A model can accurately predict risk and still produce unjust outcomes. A model can be highly accurate and still target vulnerable groups. Accuracy is a technical concept. Justice is a moral concept. Neutrality fails when people treat technical performance as moral approval. 11. Where neutrality myths show up most. Neutrality myths appear in high-stakes domains. Hiring, where companies claim automated screening removes bias. Credit, where lenders claim scoring is objective. Policing, where predictive systems claim to reduce crime. Healthcare, where models claim to allocate resources efficiently. Education, where analytics claim to identify potential. In each case, the claim of neutrality acts like a shield. It protects the institution from scrutiny. But the stakes are too high for comfort stories. 12. Content systems, when relevance is a value. Online ranking often claims to show what is relevant. But relevance is not objective. Relevant to what? To your interests. To public importance. To truth. To platform revenue. Most platforms define relevance as engagement. Engagement is not truth. It is reaction. So content algorithms are not neutral. They reflect the platform's business model. If the business model is attention extraction, the algorithm will optimize attention extraction. It will promote what keeps people watching. That is not neutral. That is profit-seeking encoded into ranking. 13. The role of classification, normal versus abnormal. Many AI systems classify people. Normal user versus suspicious user. High value versus low value. Reliable worker versus risky worker. Classification creates categories. Categories create treatment differences. Even if categories are statistical, they become social realities. People labeled risky face more scrutiny. People labeled low value receive worse service. People labeled suspicious face restrictions. Neutrality fails because classification is a form of judgment. And judgment always has consequences. 14. We do not use sensitive data is not enough. Some institutions claim neutrality by saying they do not use race, religion, or gender. This can be good practice. But it is not sufficient. Because proxies can recreate sensitive categories. Zip code can correlate with race. Education history can correlate with class. Purchasing patterns can correlate with health. Language patterns can correlate with ethnicity. So removing sensitive variables does not guarantee fairness. It can even hide bias more effectively because it becomes harder to detect. Neutrality is not achieved by deleting a column. 15. The black box problem makes neutrality harder to test. Many AI systems are hard to interpret. Even if developers understand them, outsiders cannot easily audit them. If a system is opaque, neutrality claims cannot be verified. The institution asks for trust. But trust without transparency is power. This is why neutrality myths are dangerous. They encourage society to accept systems it cannot inspect. 16. Why human oversight does not guarantee neutrality. Institutions often say humans remain in the loop. But human oversight can be symbolic. If the system produces a score, the human may defer. If overriding the system is punished, humans comply. If the workload is high, humans rely on automation to cope. So the human becomes an executor of the algorithm, not a check on it. Neutrality fails even with humans present because the system shapes human behavior. 17. How neutrality myths increase inequality. The biggest cost of believing neutrality is that it hides inequality. If outcomes are unequal, people assume it is natural. They assume the system is fair. They blame individuals. They ignore structural problems. Neutrality myths legitimize unequal outcomes. They convert power into destiny. This is how algorithmic systems can deepen inequality while appearing objective. 18. what real responsibility would look like. If neutrality is a myth, what replaces it? Responsibility. That means clear objectives explained to the public, audits to detect harms and bias, transparency about data sources, limits on high-stakes automation, appeal processes for those affected, accountability for institutions, not models, continuous monitoring of outcomes, not just accuracy. The goal is not neutrality. The goal is justified decision-making. 19. Why the future depends on governance. If society keeps accepting neutrality myths, AI systems will expand unchecked. If society demands accountability, AI can be shaped differently. Governance is not optional. Algorithms govern people. So people must govern algorithms. Otherwise, private objectives become public reality. 20. Core takeaway. Algorithmic neutrality is a myth because algorithms require objectives, data reflects history, proxies embed inequality, fairness involves moral choices, and deployment shapes outcomes. Algorithms do not remove values. They enforce values. The question is not whether an algorithm is neutral. The question is whose values it encodes and who bears the cost. If this episode helped you understand why algorithmic neutrality is a myth, like this video so more people can see it. Share it with someone who thinks math automatically creates fairness. And subscribe to Uncovering Facts for deep, hype-free explanations of technology, power, and the systems shaping modern life. Next episode, how AI quietly rewrites social rules.